No single measure completely eliminates your risk, but look what happens when they get added together. Know your risk, lower your risk.
Jai Hind, dear students. Today in this video we are going to see the last part of this lesson, exponents and powers, and that is how to represent very large numbers and very small numbers using exponents and powers. So before going to some problems, we can see the coming introduction videos. Please watch carefully.
Use of exponents to express numbers in the standard form. In our day-to-day life, we come across some statements, such as: the speed of light is this. The size of a red blood cell is this. The distance from the Earth to the Sun is this. The thickness of a piece of paper is this. Observe the numbers in these facts. These two are very large, whereas other two are very small. In both the cases, it is difficult to read them. In such cases, we can make use of exponents to express them by writing them in the standard form. We know that a number which is expressed as a decimal between 1.0 and 10.0, including 1.0 multiplied by a power of 10, is called a number in the standard form. For example, 5,985 is equal to 5.985 into 1,000 is equal to 5.985 into 10 cube is the standard form of 5,985. We can write very large and very small numbers using this method. So, let us see how to express this number in the standard form. In this number, there is no decimal point shown, means it is an integer. So, we put the decimal point at its right end. Now, the number of digits to the left of the decimal point is 12. To express this number in the standard form, we have to move the decimal point 12 minus 1, that is, 11 places, towards left, and multiply the resultant number by 10 raised to 11. So, this number in the standard form is 1.5 into 10 raised to 11. Now let us try to express a very small number in the standard form. Here, we can see that there are 6 digits after the decimal point. Since this number is very small, to express this number in the standard form, we move the decimal point 6 places towards right, and multiply the resultant number by 10 raised to minus 6. Because 0.000007 is equal to 7 upon 10 lakh is equal to 7 upon 10 raised to 6 is equal to 7 into 10 raised to minus 6.
Exponents and powers. Writing very small and very large numbers with exponents. The diameter of Earth is 1,27,56,000 meters. The size of plant cell is 0.00001275 meters. When numbers get this very large or very small, it is easier to write them in scientific notation or in the standard form. Standard form or scientific notation. A number is expressed in scientific notation when it is in the form a into 10 raised to n, where a is between 1 and 10 and n is an integer. In the previous class, we have studied the standard form or scientific notation used for expressing very large numbers. Let's try some examples. Convert the given number into the standard form. 6 crores 8 lakhs. Step 1. Convert the large number into a decimal number, where the decimal is placed after the first non-zero digit. So the number is equal to 6.08. Step 2. The number of jumps becomes the power of 10 and then multiply it by decimal number. 1, 2, 3, 4, 5, 6, 7. So, 10 raised to 7. Hence, the number becomes 6.08 into 10 raised to 7. Express the number appearing in the following statement in the standard form. Speed of light in vacuum is 300,000,000 meters per second. First, to convert given large number into decimal number, we put the decimal point after the first non-zero digit. Here, the first non-zero digit is 3. So we put the decimal point after 3 and we get 3.0. As we know, number of jumps becomes the power of 10. So here we have 8 jumps up to decimal point. So the standard form is 3.0 into 10 raised to 8. Now we can easily say the speed of light in vacuum is 3 into 10 raised to 8 meters per second. Express the numbers in the standard form or in scientific notation. Let's see the given number. The decimal point will come after 7. Hence we write 7.82. Now let's see the jumps of the decimal point. The decimal has jumped 13 steps. Hence we write 7.82 into 10 raised to 13. Let's take a look at the next number. The decimal point will come after 1. Hence it will be 1.2756. And let's see the jumps of the decimal point. We have 7 jumps. Hence it will be 1.2756 into 10 raised to 7. Let's take a look at the next number. The decimal point will come after 3, so it will become 3.1865. And let's see the jumps. So the decimal point has jumped 9 steps, hence we write 3.1865 into 10 raised to 9. Now, how can we deal with very small numbers like 0.00005, 0.0000048, 0.000000000000267? Don't worry, it's just opposite what we do for large numbers. Express 0.00001275 in scientific notation. Where would the decimal go to make the number be between 1 and 10? Correct, after 1. So it becomes 1.275. By how many places does decimal point move? 1, 2, 3, 4 and 5. When the original number is less than 1, the exponent is negative. Hence we get 1.275 into 10 raised to minus 5. Let's take a look at another one. Express 0.000005 in scientific notation. Where would the decimal go to make the number be between 1 and 10? Yes, after 5. Hence it will become 5.0. By how many places does decimal point move? By 6 places. When the original number is less than 1, the exponent is negative. Hence we get 5 into 10 raised to minus 6. Now, suppose you already have been given a number in standard form. How can we write it in non-exponential form? 1.35 into 10 raised to 5. Now 1.35 into 10 raised to 5, where 10 raised to 5 is equal to 1 lakh. Therefore, it is equal to 1.35 into 1 lakh. So move the decimal point 5 places to the right. Therefore, 1.35 into 10 raised to 5 is equal to 1,35,000. 4.8 into 10 raised to minus 6. Here we have negative power of 10, so move the decimal 6 places to the left. So 4.8 into 10 raised to minus 6 is equal to 0.00000048. Compare the following two numbers by finding the ratio. 3.24 into 10 raised to 19 divided by 1.62 into 10 raised to 15 is equal to 3.24 into 10 raised to 19 into 10 raised to minus 15 upon 1.62, which is equal to 3.24 into 10 raised to 19 minus 15 upon 1.62, which is equal to 3.24 into 10 raised to 4 upon 1.62, which is equal to 2 into 10 raised to 4. Hence, 3.24 into 10 raised to 19 is 2 into 10 raised to 4 times 1.62 into 10 raised to 15. Did you understand how to write numbers in standard form? Yes!
Hello there and welcome to Math for Juniors with my assistant Snail and me, Miss Marks.
Hello there! Miss Marks, I think I will have to skip the class today.
Why, Snail?
Well, you see, I have this science project to finish about stars and galaxies, and I have to prepare a whole lot for that. So, bye!
Hold on, Snail. Did you say galaxies? Stars?
Yes, Miss Marks. Nothing to do with math.
Snail, can you tell me how many stars are there in our Milky Way galaxy?
Of course, Miss Marks. About 100 billion.
Good, Snail. There are about 10 raised to power 21 stars in the entire universe.
No!
Stop overreacting. Now you tell me how many more stars are there in the universe than our Milky Way galaxy.
Let me write down 100 billion. And what did you say? 10 raised to 21. 100 billion is equal to 1,0,0,0.
Snail, don't get stuck with your calculation. There's no escaping math, huh? All you have to do is learn scientific notation to write the large numbers so that you can compare them in no time.
Scientific notation? That does not sound like math.
It's very much math, Snail. Come on, let's enter the virtual world to learn more about scientific notation, or how to write large and small numbers in the same style. Many measurements in modern scientific field involve very large and very small numbers. The approximate average speed of a spacecraft is equal to 17,374 meters per second. This can be conveniently approximated to 17,400 meters per second. Every number, large or small, can be expressed in decimal form as the product of a number between 1 and 10 and an integral power of 10. Thus, the approximate average speed of a spacecraft, which can be approximated to 17,400, can be expressed in a standard form as 1.74 into 10 raised to the power of 4 meters per second. General format of expressing numbers in the form of multiples of powers of 10 is known as standard form or scientific notation. Expressing numbers in standard form helps ease calculations. The general form of the standard form of the number x is a into 10 raised to the power of n, where a is a real number between 1 and 10, that is, including 1 and excluding 10. And n is any integer positive for large numbers and negative for small numbers. Let's see how we can write number in standard form. First, move the decimal point to the left or the right as may be necessary to bring one non-zero digit to the left of the decimal point. If you move p places to the left, multiply by 10 to the power of p. And if you move p places to the right, multiply by 10 raised to the power of minus p. The value of the p depends on the number of places you have moved. Snail, now can you tell me how to write the number of stars in the Milky Way galaxy?
Miss Marks, so many numbers. A number jumble in my head. A jungle of numbers, a jumble of...
Snail, come on. Switch into high gear. This one is really easy.
I don't know, Miss Marks. The value of P got me really lost.
Well then, let's say, Snail, you are the decimal. Next to you on the left are the 5 chairs representing numbers. 4 of them are red and the first one from the left is green. To convert to scientific notation, where should the decimal move to?
Oh, I must think fast. To convert to scientific notation, I must stand next to the green chair.
Now remember, the value of P is the number of places you have moved. So, how many chairs did you skip?
1, 2... I skipped 4 chairs to the left.
That's it. So the value of P is?
It is 4, Miss Marks. Wow, that was fun and so easy.
Easy. And now, let's make it easier still. Into the virtual world for more on writing really small numbers. Let's consider another example involving an extremely small number. The wavelength of violet light is approximately equal to 0.0000038 centimeters. To express it in standard form, move the decimal 5 places to the right. So we obtain the value 3.8 into 10 raised to the power minus 5 centimeters. Back from the virtual into the real world of math. Now, Snail, how many zeros are there in your number of stars?
11, Miss Marks. So I am skipping, hop and a skip, and
I don't have all day, you know that, Snail.
oh yes, got it. So it's written as 1 into 10 raised to the power of 11. Correct, Miss Marks?
Absolutely. Now, do you think you can subtract and find out how many more stars are there in the universe than the Milky Way galaxy?
Miss Marks, no.
Snail, let's enter the virtual world to learn how to carry out operations on these numbers. In order to carry out the multiplication of two such numbers, the coefficient of the two numbers are multiplied to get the resultant coefficient. Whereas the exponents of the two numbers are added to get the exponent. To carry out the division by using scientific notation of two such numbers, the coefficient of the dividend is divided by coefficient of the divisor to get the final coefficient. Whereas, to get the final exponent, the exponent of the divisor is subtracted from that of the dividend. In case addition of two numbers is to be carried out by using their scientific notations, first, the exponents of the two numbers are made equal. This is done by appropriately changing the position of the decimal in the coefficient of one of the numbers. After that, the two coefficients are added to get the coefficients of the sum. Whereas the exponent of the sum will remain same. Similarly, subtraction by using scientific notations is also carried out by making the two exponents equal. Later, the difference between the coefficients of the two numbers is obtained, which becomes the coefficient of the final difference. Whereas the exponent of the difference will remain same. Well, Snail, we are back. Did you figure out the difference?
Yes, Miss Marks. It is 10 raised to power 21 minus 10 raised to power 11.
That's great! Did you see how easy life becomes when you can write numbers that quickly, big or small?
Yes, Miss Marks. But I have a doubt.
Shoot, Snail. Hurry up now.
Well, Miss Marks, I was just thinking if the number of hair on my head can be written in the scientific notation.
Counting your hair? Oh, why, Snail? I could give you a lot more work if you are that free. Oh God. Come on now, let me tell you something about calculators. Do you know that frequently calculators and computer programs present very large and very small results in scientific notation? And the reason is that exponents as big as 10 raised to power 7 just may not fit on the screens of your calculators and some computers.
Is that so, Miss Marks?
Yes, so a different format troubleshoots this problem. The letter E or small e means times 10 raised to the power of in this system. It replaces the into 10 followed by the value of the exponent. For example, 6.022141.8e23 is equal to 6.022141.8 into 10 raised to power 23.
That's wonderful, Miss Marks. I love calculators.
And now, let's take a short sprint back and jog our memory on what we have discussed today. In the standard form, a number x is written as a into 10 raised to power n, where a is a real number between 1 and 10, including 1 but excluding 10, and n is any integer, positive for large numbers and negative for small numbers. It's important to express numbers in standard form in order to compare large and small numbers. So that's all we have for you today on the show. Hope you enjoyed skipping places as much as Snail and I did.
Oh, Miss Marks, I thought it's going to be so tedious and dull, but it really wasn't.
That's good enough, Snail. So keep counting until next time. Goodbye.
Bye.
Dear students, now we are going to see the last part of this lesson, that is how to use exponents to express small numbers and large numbers. I hope that from the introduction video you got an idea how to write the larger numbers and very small numbers in the form of exponents, that is using the power of 10, using 10th powers. Okay, so from that video you might have gotten a clear concept about how to write these exponents to represent small numbers and large numbers. Now we are going to see some more examples. So all these examples you need to copy in your maths notebook and also complete the homework in the similar way. Okay, so we can just do some more examples. So the first example you see, so the heading is use of exponents to express small numbers and large numbers. Okay, so exponents can be used to represent very large numbers and very small numbers also. Okay, so how we are doing this problem, all of you see. First one, the distance from the earth to the sun is, this is a very big number, understand? So 149, this is given in international system. So 149,600,000,000 meter is the distance from the earth to the sun. Now what we are going to do, we are making this number in the form of using exponents. We are representing it in their standard form. Okay, so how we can do that? How we can do the answer? From the introduction you might have learned that first you want to place the decimal after the first number. Okay, so here the first number is 1. So we can put the decimal after the first number, it becomes 1.49600, and how many zeros? 1, 2, 3, 4, 5, 6, 7, 8. So 8 zeros, understand? So now we made the decimal after the first digit. Now what we want to do, that is equal to this into 10 to the power. Now you placed the decimal after 1. So now you want to count the numbers after the decimal, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers are there. So actually the decimal was here and we placed after 1. So 11 places were jumped onto the left side. So the value is 1.496 and 8 zeros into 10 to the power 11. Okay, so the decimal we placed after 1. You want to count the remaining numbers. There are 11 numbers. So you want to write into 10 to the power 11. Okay, so this is the standard form of this actual number. Now come to the second question. Thickness of a piece of paper is 0.0016 centimeter. So this 0.0016 means it is actually a very small number. So here you see, if you want to write this in the standard form, First you want to place the decimal after 1. So here 1.6. Okay, only one number more, 1.6. Now you see the question. Actually the point was here. So we made it after 1. So from after 1 you want to count up to the original place. So here 1, 2, 3. 3 places left side. Left side means it is negative power. So this is equal to 1.6 into 10 power minus 3. Understand? So if we move the decimal from left to right, we want to use negative power. From right to left, we are using positive power. Okay. Yes. Now we can do the next example. The height of Mount Everest is 8,848 meter. So here actually there is no decimal. So if there is no decimal in the number, it means the decimal is in the last place. So how to write this 8,848 in the standard form? Yes, place the decimal after the first number. So 8.848 into 10 power. If you place the point after 8, how many numbers more? 1, 2, 3. Right side. So it is 10 to the power 3. Okay. So this is the standard form of the height of Mount Everest. Understood? Now you are having the question like you are having in the exercise also. Write the numbers in standard form or scientific notation of numbers. So when we are writing in this form, it is called standard form, or otherwise we can say it is scientific notation. Okay. So the given number, very large number or very small number, you want to represent in standard form. Okay. So here write the following numbers in standard form. First question, 4829 and 4 zeros. So how to write this in standard form? First write once the question, and this is equal to, place the point after the first number. So it becomes 4.829 4 zeros into 10 to the power. How many numbers we before we put the decimal? That is 1, 2, 3, 4, 5, 6, 7 numbers. Okay. So 7 numbers are after. So 10 to the power 7. Understand? Okay. Now the next question, 5 and 3 plus 3, 6 plus 3, 9 zeros. So 9 zeros before we are placing the point here. So 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. This number is equal to, because here it is point after zeros, you can delete those zeros. No need of writing that. So just 5 into 10 to the power, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 to the power 9. Understood? Yes. Now the next question, you see this is a very small number, 0.12345, 5 zeros, 1, 7, 8, 9, 2, 3. So how to write this? 0. When it is a very small number, the power will be negative. Okay. So here first you want to place the decimal after 1. So 1.7893 into 10 to the power. Yes, how many places we moved the decimal? From here to here, right? So after 1, from here we want to count. So it is 1, 2, 3, 4, 5, 6 places we moved. Okay. So it is 10 to the power minus 6. Understood? Yes. One more question from here. 0.00254382. This is also a very small number. So here you want to place the decimal after 2. So it becomes 2.54382 into 10 power. So to place after 2, how many places we moved? 1, 2, 3 places. Okay. So 3 places to the left side. It is a small number. So negative power 10 to the power minus 3. Understand? So every time when you are writing in standard form, whenever you place the decimal after the first number, that number want to be between 1 and 10. Okay, including 1 and excluding 10, as you saw in the introduction video. Understood? So like that you want to make the number first and accordingly put the 10 power. Understand? If it is a very small number, negative power will come. If it is a very big number, positive power will come. So this is the way to represent very large numbers and very small numbers as standard form. Understand? Okay. Now children, we are going to see the next type of question, that is express the numbers in usual form. Usual form means its normal form. Okay. And the question will be given in standard form. So when a question is given like this, that is a number, decimal number into 10 power something, then the meaning is this is in standard form. So you want to remove the decimal and convert. Remove the decimal means move the decimal according to the powers of 10 and convert into the usual form. Okay. So here we are going to try some questions. 4.08 into 10 power minus 5. Okay. So you know that negative power means you want to move the decimal towards left side. Understand? So here minus 5 means 5 places you want to move left. That is the meaning. So here in this question the decimal was after 4. After 4 means from here you want to count 5 places left, means it will come that is 4 is first number, and because there are no other numbers you want to add zeros. Correct? So how many zeros will come there left of 4? Yes, 4 zeros, because 5 places we want to move the decimal, so that 0.4 first place, then remaining 4 zeros we want to put. So this can be easily written as 0 point. Whenever you are writing a very small number, first you use 0 point. How many zeros? 4 zeros, and this 4, 0 and 8. So this came into the usual form. Understand? So see the power of 10, and when it is negative, move the decimal to the left side, and when it is positive, move to right side. Understand? So because here only one number present on the left of decimal, we added 4 more zeros. Understood? Yes. Now come to the next question. 3.2963 into 10 raised to 4. So here 10 raised to 4 means positive number, positive exponent. So move the decimal to the right side. So here this is equal to, you see, 4 places to the right. So here from the decimal will move 1, 2, 3, 4. So it will come after the last number. So when the decimal is coming after the last number, no need of putting it. You can just write 32963. That is the answer. So this is the usual form. Now come to the next question. 1.008 into 10 power 9. So here also positive number, you want to move the decimal to the right side. How many places? 9 places. So already here 3 numbers are there. So 6 numbers are not there. So you want to put 6 more zeros. So it can be written as 1008. Understand? And put 6 zeros. 1, 2, 3, 4, 5, 6. Now this came into the usual form. Okay. Yes. Next 4.9 into 10 power 4. Here also positive exponent. So move the decimal 4 places right. Here only one number. So you want to put 3 more zeros. So this becomes 4, 9 and 1, 2, 3 more zeros. Okay. Yes. Next question. 9 into 10 raised to minus 8. So here you see 9 into 10 raised to minus 8. So minus 8 means you want to move 8 places to the left side. Understand? So here 9 only one digit. So the decimal is actually here. So you want to move how many places? 8 places to the left. So only one digit is present. So count that first number and how many zeros will come? Yes, very good. 7 zeros will come. Okay. So this represents a very small number. So you want to put 0 point, how many zeros? 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros and this 9. Okay. So this represents the usual form of the number. Now one more question. 2.0026 into 10 to the power minus 11. So here 11 places you want to move left. So see the number here. Only one number present here. So how many zeros you want to go to the left side? Yes, 10 zeros. Okay. So this number 1 and remaining 10 places you want to put 0 on the left side. So this becomes 0 point. Because this is a negative exponent, this represents a very small number. So 0 point, how many zeros? 10 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. And this 2, 0, 0, 2, 6. Okay, so this is a very, very small number and this is the usual form of the number. Okay. Now we have one more important question from your exercise 12.2 question number 4. What is the question? In a stack there are 5 books. Okay. Each of thickness 20 millimeter and 5 paper sheets each of thickness 0.016 millimeter. So what do you mean by a stack? Stack means actually the arrangement of books one above the other. So we are arranging books and paper sheets one above the other. So this arrangement is called a stack. Okay. So in these stacks, what are the things present? 5 books are present and 5 paper sheets are present. Okay. And given that one book, each of thickness, the thickness of one book is 20 millimeter. So how many total books are there? 5 books. So you want to find the total thickness of these 5 books. And also paper sheets are present 5 numbers and each paper sheet is having how many thickness? 0.016 millimeter is the thickness of each paper. So you want to find out the total thickness of these 5 paper sheets. And it is asked what is the total thickness of the stack. So adding all these thickness of 5 books and 5 paper sheets, you want to find the thickness of the total books. Total books with the total paper sheets. And here the important thing is whatever answer you are getting, you want to convert into standard form. Understand? Yes. So because it is a word problem, you just want to write the steps. Here what is given? Thickness of each book is 20 millimeter. So you can write directly total thickness of how many books are present? Yes, 5 books. So total thickness of 5 books is equal to 5 multiplied by 20 millimeter. Correct? Because 20 millimeter is the thickness of one book. So which will give you 100 millimeter is the total of 5 books thickness. Similarly, you want to find the total thickness of paper sheets. So total thickness of how many paper sheets are present? 5 paper sheets. So 5 paper sheets thickness is equal to 5 into thickness of one paper is 0.016 millimeter. So when you multiply this, you will get 0.080 millimeter as answer. Okay. Now you want to find the total thickness of the stack. Means you want to add these two answers. So therefore total thickness of the stack is equal to 100 millimeter plus 0.080 millimeter. Okay. So when you add these answers, you will get 100.080 millimeter. So we got the answer. But the thing is, you want to write this in standard form. How to write? Yes, this is equal to, first you want to place the point after the first number. So 1.00080. Understand? and into 10 power, yes, when you place the decimal after 1 point, okay, so how many places we moved? Actually 2 places, right side. So right side was the point, we moved it to left side. So the power will be positive, okay. So we want to make the decimal actually after 2 places. So you want to put into 10 to the power 2, okay, 10 to the power 2, write the unit millimeter. So that is the required answer. Okay children, so hope all of you understood how to represent very large numbers and small numbers in standard form and how to write in usual form. So all of you practice all these questions very well, write your notes very neatly and complete the homework problems also. So with that, this lesson is over. So all of you revise this lesson properly and study well. In the next class, we will come with a new lesson. Okay? Complete the homework of exercise 12.2, questions 1, 2 and 3, all the problems, and submit to your respective teachers. So meet you in the next class children. Thank you.